Hello everybody, this is Mr. Willis, and I'm going to talk with you today about trigonometric functions, or trig functions. You may also hear them called trigonometric ratios. The basic trig functions that we are going to talk about today can only be used with right triangles. Okay, and so that means that that we are going to have a triangle that has a 90-degree angle in it somewhere. All right, so we're definitely going to be working with right triangles, and just keep that in mind. All right, a trig function is a ratio between two of the triangle sides. And so if I, again, I'll just draw a right triangle. It's going to be a ratio between two of our sides. Now, oftentimes we will use a Greek letter theta to label. Okay, I'll draw it nice and large. That's what a theta looks like. It is a capital theta, a capital Greek letter theta. And I'm going to use that just to denote or label this angle. So this is angle theta. Okay, nice to meet you. All right, now when we look at our triangle, once I label angle theta, I can also then label the sides. Now, and if we're going to talk about the ratio between two of the sides, we need to know what sides we're dealing with. Okay, so the first side is the one directly across from theta, and that is going to be called the opposite side. Okay, and I'm sure that you can figure out why, because it is opposite or straight across from theta. So the one right there is the opposite side. The next one we're going to talk about is the one next to theta, okay, called the adjacent side, because it is adjacent or right next to the angle theta. Now I hear what you're saying and thinking, but wait, Mr. Willis, what about this other side up here? Isn't it also next to theta? It is, but it is directly across from the right angle and is the longest side of the triangle. And so it has a special name. It is the hypotenuse. And so it is not available for lesser roles like adjacent. It is in the starring role of hypotenuse. Okay, so we've got our three sides: the opposite side, the adjacent side, and the hypotenuse. And all those are relative to where theta is. If I had drawn my triangle this way and chosen to put theta in this corner, then the opposite side would have been here, the adjacent side would have been this one, and of course the hypotenuse is still the longest one directly across from the right angle. Okay, so that is that. All right. Let's see, just gonna get rid of that real quickly. Okay, get it out of the way. All right. Something else that you'll notice up in the notes. Don't watch me erasing. There we go. We're done. Is that the trig functions that we're going to talk about are sine, cosine, and tangent. Okay, and this is the way that they are actually written and spelled. All right, so we'll have a little conversation about those. Now, first of all, I want to show you. I'm going to put two triangles here, and I'm going to overlap them. And as I do that, I want to talk about why the trig function stays the same no matter what size your triangle is. All right. So let's say that I label this side theta. Now, you can see that these triangles have a common angle, okay? And they also both have a 90-degree angle. And so since this angle in both my green and my red triangles since this angle is the same, and since this angle is the same, since two of them are, then we understand that the third angle is also the same. And so those two angles are congruent to one another, and that just means that they have the same measurement value. All right, so we have those angles. Now, since all three angles are the same, then these triangles are similar, and what that means is that the sides are proportional. And so if I took this green triangle and stretched it, if I could highlight it and stretch it, it would grow until it matched this red one exactly. And that's because these are similar triangles and are proportional to each other. All right, so as we look at that, so here's what I want you to see. If let's just say that this green triangle, so I'll label in green, let's say that this side had a value of 6, that is a length of 6, and that this side had a length of 2. All right. Now let's look at our red. If we increased this proportionally, let's just say that we doubled each side. I didn't quite make the red one twice as big, sorry about that, but let's pretend, use your imagination just a little. Let's say then that I measure the red one and this side is actually 12. Okay, so if this side is 6 and this side is 2, if my red side here is 12, what do you think the length of this side will be? And you are correct, it is in fact 4. And that's because, again, with the sides being proportional, it doesn't matter if it's 6 to 2 or 12 to 4, that is still the same ratio. Okay? And so whether it's 6 over 2 or 12 over 4, both of those would actually reduce to 3 over 1, or just 3. And so that would be the ratio of those two sides together. All right? And so that's what we're going to be talking about today, is we're going to be looking at, so it turns out that there are values for sine, cosine, and tangent, and those values remain the same no matter how big the triangle is. And so by knowing one side, and by knowing your angle, and by knowing your sine calculation, you can actually calculate the value of the other side. I know that sounds a little confusing, but we're going to walk through it one step at a time. Okay, so let's look at. Let's see. Let me go back and erase these guys here. All right, so got that erased, and we're going to take a look at the. We're going to take a look at what the value, or what the ratios are for sine, cosine, and tangent. So let's just look at this. Now, first of all, sine, cosine, and tangent, whatever the sine is varies depending on the angle that you're talking about. So when we say sine, it's not just sine, it's sine of some angle, and remember that we used theta to mark that. So sine of theta, cosine of theta, and tangent of theta. And it turns out that the sine of theta is always equal to the ratio of the opposite side divided by the hypotenuse. And the cosine of theta is always equal to the adjacent side divided by the hypotenuse. And the tangent of theta is always equal to the opposite side divided by the adjacent side. All right, and so those are the values for our trigonometric ratios. Now, the way that we're going to use those is let's just draw a triangle. Let's see. And let's say that I have my angle theta here. And let's say that I know a value for theta. Let's say that theta is 25 degrees. That looks reasonable. It may be a little more than that, maybe 30-ish, but we're just going to say 25 just for fun. Now that I've labeled theta, I want you to go ahead and decide about the sides. Okay, and I'm going to say that this side has a value of 15. All right, and so what we'll do is we'll look at that, and now this side over here will be the, I'm just going to call this side y because it's vertical, and I'll call this side x. Now y happens to be the opposite side, and x happens to be the adjacent side. Okay, so let's remember that as we go through. In fact, yeah. So we'll go ahead and do that. Now, let's say that I'd like to find the value for y. I'd like to find the value of this. Now, since and 15 of course is my longest side, and so that is going to be equal to my hypotenuse. So let's say that I'd like to find a value for y. I'd like to find this height value here. I'm going to look and I'm going to say, okay, what do I know and what do I need? Okay, well, I currently know theta, and I know my hypotenuse, and I need my opposite function, or my opposite length. Okay, and so I'm just going to look at my trig functions here, and I'm going to say which one of these involves theta, hypotenuse, and the opposite side. Okay, and after a quick review, I'm going to see that that is in fact going to be sine, because I can see that sine theta is equal to the opposite side divided by the hypotenuse. All right, a shorthand way to write sine is just to abbreviate with 3 letters and stop after the n. So sine theta equals opposite divided by the hypotenuse. And let's just go ahead. These are actually, this is actually a math function. So let's go ahead and put in our numerical values. All right. So let's see. So if we kind of continue on here to the side, sine of 25 is equal to the opposite side, which we don't know. So I'm just gonna, so I could leave it as opposite, or I could put in my y. So I'll just put in y divided by the adjacent, by the hypotenuse. And the hypotenuse in this case is 15. Okay, so I've got sine 25 equals y over 15. Now, sine 25 is actually a value. If you type sine 25 in your calculator, be sure your calculator is in degrees, because you will get very different answers between degrees and radians. And right now we are working with degrees. So please be sure that your calculator is in degrees. But right now, if you type sine 25 and just hit equal, it will give you a value. And that value is actually the ratio between these two sides. All right. Now, since this is a fraction and this is an actual value, it's just represented with a function, I can multiply both sides by 15. Okay, so if I multiply both sides by 15, then we can see that that will cross out, and then I'll have 15 here. So at this point, I've got 15 sine theta equals y. Okay, so I'll rewrite that. 15 sine theta equals y. Okay, and you can actually take a moment, just type 15, hit the trig function button and find sine, and then type in, instead of theta, let's actually type the value that we have. Let's put 25. Okay, so 15 sine 25, and that will give you a number. I've come to class without my calculator, so I am not going to tell you what. I just need to pause and go get my calculator. All right, and as I punch in on my trusty calculator, 15 times sine of 25, I get a value for y of 6.34. Okay, 6.34. And so that means that the length of this is actually 6.34. So I will take a moment and let's just go ahead and write that down for information. Okay. And let's see, let's come over and pick up a yellow. All right. And 6.34. All right. Now let's see. Let's say that at this point I actually have a value for the hypotenuse and I have a value for this side, and so I could use the Pythagorean theorem, a squared plus b squared equals c squared, and I could solve for the adjacent side that way. But I'd like to go ahead and continue practicing using my trig functions. All right. So so I'm just going to take a moment and erase all of this. All right. Okay, and let's press on then with so now I know my opposite side and I know my hypotenuse and I want to know my adjacent and I also know theta. So I could literally use either cosine or tangent. I'm going to choose to use cosine just because that will avoid using a calculated value. And whenever you can, it's better to use given values than calculated values. So I'm going to use cosine because I know theta, I know the value for the hypotenuse, and I am looking for the adjacent side. All right. So I'm going to again write this out, and I'm going to say, hey, the cosine of theta is equal to the adjacent side divided by the hypotenuse. All right, and then I'm going to substitute my values in, and so cosine of 25 is equal to the adjacent side, which I'm going to call x, divided by, let's see, again, my hypotenuse is 15. All right. And we can see that just like I did last time, I've got my unknown value here in the top of a fraction. I've got this function and this number. And so I'm just going to multiply both sides by 15, cross those away, and have the 15 on this side. All right, so carrying that across, we'll have 15 cosine 25, and that will equal x. And I'm going to type that in on my calculator. 15 cosine 25, and I get, in this case, 13.59. So 13.59. And so what we see is at this point I've found values for all of my sides. And so if I have a triangle, a right triangle, with an angle of 25 degrees, then I can know that if the hypotenuse is 15, then the short side would be 6.34, the longer side would be 13.59. And of course, the functions remain the same, so that if I increased it proportionally, these would all increase proportionally as well. All right. Hey, let's do one more example, just for fun. We'll draw another one and maybe use. Let's just see what we can find here. Okay. So I will add new layer for us, and let's go to work. All right. So let's make a nice large triangle. Ooh, triangle without a straight side. That's okay. It's still a right triangle. And And I'm going to label. I tell you what, let's label this one this time, just for fun. So we'll say that is theta, and we'll say that theta is equal to. We'll say that theta is equal to. It looks like a little more than 40 degrees. We'll say that's equal to 50 degrees. So we'll say that theta is equal to 50 degrees. Again, it may be a little more, maybe closer to 55 or 60, but we're just going to go with it. All right, and I'm actually going to say that this side is 24. All right, so now that I've labeled theta, and I'm going to say what are the values of the other two sides. So now that I've labeled this side with a value, and I've said that that is theta, the next thing that I need to do is decide. Okay, let's see. Let's just label. All right, so that's going to be my opposite side, and I won't give it a name this time. I'll just call it opposite, and the hypotenuse directly across from the right angle, so we can just, and the longest of all the legs of the triangle. So this is 24, and so this is my, I'm just gonna put in parentheses here for us in Panther purple. Ooh, that doesn't show up very well, but this is the adjacent side. All right, I'm very sorry, Panthers. We are gonna have to do something different with that. All right, so let's see. Panther purple is going to turn into, we'll just do kind of a red. Red shows up well, and so that's the adjacent side. All right, so there we have that. So 24 is the adjacent side. I'm just going to real quickly sketch out again. If you remember the some people use the term SOHCAHTOA, which stands for sine, the opposite over the hypotenuse. So of course sine of theta equals the opposite divided by the hypotenuse. Cosine is equal to the adjacent divided by the hypotenuse. So cosine of theta equals the adjacent side divided by the hypotenuse, and TOA reminds us that the tangent of theta is equal to the opposite divided by the adjacent. Okay, and so tangent of theta is equal to the opposite side divided by the adjacent side. All right, so right now for my givens, I have theta, and I have the adjacent side. And which means that I will be, of course, all these have theta, and I can see that my adjacent side is here and here. So I'll be working with either cosine if I want to find the hypotenuse, or tangent if I want to find the opposite side. And you know what? We have not used the tangent function yet. So let's do that just for fun. All right. So since I know theta and and opposite happens to be one of the ones we're looking for, let's just go ahead and do that. I'll write down our formula. Tangent of theta is equal to the opposite side divided by the adjacent side. Tangent of, let's fill in our values. Theta was 50 equals, and the opposite side is still what we're looking for, so I'm just going to leave it as an O. I'm going to leave it as a variable, and divided by the adjacent, which is 24. All right, now again, solving that, multiplying both sides by 24. And so I'm left with 24 tangent 50 equals the opposite side. And so punch that into my calculator, which I have checked to see is in degrees. 24 tangent 50. And I get 28.60. Okay, so I'm just gonna 28.60. 0 for the opposite side. All right, and so there we have that. And let's go ahead and solve for the hypotenuse, and let's do it using this, because we haven't really had to move the math around too much. Let's do that one, and we'll move the math around a little bit. Okay, so I'm just going to kind of make us a little workspace here. All right. So once again, this time I'm looking for the hypotenuse, and I've decided, I can use that since I know theta and I know the adjacent. So I'm going to do that. I'm going to say, hey, cosine theta is equal to the adjacent divided by the hypotenuse. And I'm going to rewrite that. Cosine of 50 is equal to the adjacent side, which is 24, divided by the hypotenuse, which I'm going to leave as h. Now, in case you're wondering, I could have chosen to move the letters around here before I put the numbers in. Nothing wrong with doing that. Some people prefer that. Others prefer to put the numbers in first. It's just whichever you personally are comfortable with. Now, this time, you'll notice that that the h is on the bottom. It's in the denominator. So we need to get that out from under there. And so again, we'll multiply by h on each side. And so when I do that, multiplying h on each side, I'll actually have h cosine 50 equals 24. Okay, well that's lovely, but I didn't want h cosine 50. I wanted just h. And so the way to get h by itself is actually to divide both sides by cosine 50. And so when I do that, I will have the, let's see, I'm just going to mark out cosine 50 there. So at that point, I will have h equals 24 divided by cosine 50. And I will do the math on my calculator. Again, cosine 50 is a number, and so I can just put it in, I can just type cosine 50 in there, and the calculator will give me a number. So 24 divided by cosine 50. And I get 37.34. So the hypotenuse value is 37.34 units, whatever we are measuring in. All right. Thanks so much for your time today. I hope that was helpful, and I wish you the very best of luck in your physics calculations. Bye-bye.